Hello friends, welcome to the channel. This is Top Educator Akash. Today I'm back with a new video of physics, the chapter 1 electricity, and this is the part 2. So let us discuss the entire concept within Mindmap revision. So let us start the chapter. So in the previous sessions we covered till resistivity. So in this session we are going to cover combination of resistance and heating effect of current and power. So let us start with the combination of resistance. So as we have discussed that resistance is nothing but opposition to flow of charges or current. So how we know that resistance is opposition. So how this opposition is created? This opposition is created by the atoms in the conducting wire, as well as there is also a device that is creating resistance, that is resistor. These resistors, or we can use the any appliances that also has resistance. So how this resistance has to be connected in the circuit? So let us start. So there is some sound hearing. It is my palace. It is the construction of my palace. So don't go there. So let us start the series and parallel combination. There are basically two combination, that is series as well as parallel. So let us discuss first series combination. So what is series combination? So when the resistors are connected to end, then the resistors are said to be in series combination. So let us explain deeply. So as I said that the resistance are connected to be in end-to-end connection. How it is connected? Let us discuss it. Suppose it is the circuit, and as I have said that the symbol for resistor is somewhat like it, and if the resistors, this is the series combination, if the resistors are connected in series, they will be connected like this. That means end to end. This part of is this end is connected to another resistor, this end, and this end is connected to, you can observe here, another end. That means this end is connected to another end of resistor, and this end is connected to another end of another same resistor. So we can tell that this is nothing but end to end connection. So the resistors which are connected in end to end is nothing but series combination. So let us discuss how the current flows in series combination. Here I have given the circuit. It is of parallel as well as series. So you can, it is series combination, and it is voltmeter and it is ammeter. So this is connected in parallel, as I have said that voltmeter should be connected in parallel combination. So what happens in series combination? Let us discuss. So combination of resistance and the resistance in series. So what happens? So let us consider there are three resistors. One is of R1, other is of R2, and other is of R3. So these are connected in series. So the equivalent resistance across the circuit will be R1 plus R2 plus R3. So how it is derived? Let us explain this. I have given the derivation of this formula in Mindmap as well. So you can download this Mindmap in the link description given below, so that you can complete revise the chapter within few minutes. So how it is derived? So as I've said that it is connected in end to end. So what happens in end to end connection? So here, this is the series combination. I have given explanation with animation. You can observe here. This is the, let us assume it as voltmeter, and another, it is not voltmeter, it is battery. So suppose you assume it as battery, and when current flows through it, you can observe here, here the current is not getting divided by another wire. It is flowing simply straight, but it is getting opposition by R1, R2, R3. So we need to calculate how much is the opposition, that means resistance. So we can say that in the series combination the I, that is current, remains same. So what remains same, that is current, and one more term that gets divided, that is V, voltage divided. So you need to remember this, the current remains same and the voltage get divided. So we can derive this formula as I have said that voltage get divided. Let us assume that the equivalent voltage be V, that is V1 plus V2 plus V3 is the total voltage. So as we know that by Ohm's law, V is equal to IR. So let us assume that V1 is equal to IR1. So why it is I? It is because I remains same across all resistors. So V1 is equal to IR1. Similarly, we will get as IR. V is nothing but IR. So IR is equal to IR1 plus IR2 plus and IR3. So now you take the I as common. What will you get? R1 plus R2 plus R3. So now you can cancel I and I. What is remaining? R is equal to R1 plus R2 plus and R3. So we can say that resistors in series, that I have given the derivation here itself, so you can observe here and read properly. So what we can say about the resistance in series, that is sum of all resistance is more than the individual resistance in series. That means the resistance of one is lesser than the sum of all resistance. So similarly, what we can say about total resistance is nothing but sum of all resistance is nothing but equivalent resistance in series. So similarly, we have parallel combination. So what we have parallel combination, let us discuss about it. So I will be discussing with the resistance in parallel. So what happens in resistance in parallel? So 1 minute, this is the parallel combination, and you can observe here I have given how it is connected in parallel combination. So when the resistors are connected together between the same point, then the resistance is said to be in parallel combination. So let us discuss about it. I will be discussing with you. So I have given this parallel combination with animation. So this is the battery. That means voltage is created. So the electrons are moving, and I here you can observe the current is I here. Now the electron direction get three directions, so it has to move in three directions. One is here, one is here, and one other is here. So we can say that the electrons get divided. That means the current gets divided here, I1, I2 and I3. And you can observe here the resistance are connected in one above the other, but the wires are not connected end to end. That means they all are connected together at same point. You can observe here, and these all are connected at same point. So this we can say that these are connected in parallel combination. And similarly, the I is getting divided. I divides here, and V is same, that is voltage remains same. So this term you need to remember. So let us derive this formula. As I have already said that I divides, so total current will be I1 plus I2 plus I3. So that is according to Ohm's law, it will be V by R1, that is equal to V by, so this is not R1, it is RP, that is resistance in parallel. So V by R1 plus V by R2 plus V by R3. So similarly you can take V as common here. V by V1 by R1 plus 1 by R2 plus 1 by R3. This is 2, and here you can observe V and V gets cancelled. What is remaining? That is 1 by Rp, that is 1 by resistance in parallel is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So we can get this formula. So let us move to the next topic, that is heating effect of current. So here there is a term called Joule's law of heating. So what is Joule's law of heating? Before discussing, let us discuss what is heating effect of current. So I have already said that there is some resistance in the circuit. So what happens, one minute, this is the conducting wire, and here will be some atoms. So right here will be some atoms, and you can see that electrons will be moving. So the electrons will be moving, then what happens, the electrons get struck by these atoms. So what happens by striking? Suppose you think that a hard rock falls from a building. What happens? That the energy is converted into heat, and some energy is converted into sound, some in potential energy. So as we can say that some energy is converted into heat energy. Why it is converted? Because both objects obstruct each other. So due to that, some amount of heat energy is converted. So why it is converted? This is nothing but heating effect of current. That means in the circuit some amount of heat is also generated due to this resistance, due to this oppositions. So this is nothing but heating effect of current. So based on this, many appliances work. Before moving to the appliances, let us know what is Joule's law of heating. Joule's law of heating is nothing but when H is equal to I square RT. This is the formula for Joule's law of heating. Before knowing to the formula, we just need to know the statement. So what is the statement? Statement is nothing but the heat energy produced in the circuit is directly proportional to square of current and resistance across the circuit and the time taken to flow the current. This is just simple way of defining Joule's law of heating. So what is the formula? I have discussed that. Formula is nothing but H is equal to I square RT, that is square of current into resistance into time taken. So I have said that it is directly proportional to I square R and T. So let us know what appliances work on this formula. I mean the principle, that is electric heater, fuse, bulb and electric iron. Many appliances work on this principle. So let us study about it. I will be explaining you the one appliances that is important for your syllabus, that is fuse. So this is fuse. You can observe here, this is the fuse appliance that was mostly used before, but nowadays a different appliance, that is MCB, is used. So miniature circuit breaker. So but we need to study the fuse itself in this topic. So what is fuse? A fuse is appliance that protects our appliances. That means it is a device that protects our appliances from short circuits or some explosions. what happens in fuse wire? So what is fuse wire? So this is fuse, and here one wire is connected here. What is the fuse wire? This wire which melts and breaks the circuit and prevents damage of various appliances in household connections is called a fuse wire. That means this there is a wire connected here. This wire is made up of alloy of aluminium, copper, iron and lead. It is an alloy of aluminium, copper, iron and lead, and this wire has very low melting point. Suppose whenever the excess amount of current flows through it, then it automatically gets melted and the circuit gets broken, and the excess amount of current passing through the appliance that is stopped, and the appliances gets protected and it prevents from damage. This is the what we can say that this is the function of fuse. Now one more important thing of fuse wire, that is the thickness of fuse wire increases the maximum safe current that can flow through it. So this is also an important thing that is in the fuse wire. Now next, as I discussed the heating effect of current, next is power. So what is power? In the previous classes you have already studied about power, so let us study more. So how we can define power? Power is nothing but electric energy per unit time is nothing but power. Per unit time, here the nothing but electric energy by time. So this is the formula. So energy can also be defined as work. Capacity to do work is nothing but energy. So we can say that W by T is also a formula. So what is the unit? That is watt. Watt is the unit to measure power. So P is equal to W by T. As I have already discussed you that V is equal to W by Q, and W is nothing but VQ. So we can write P is equal to VQT. So we can also write P is equal to VQT. QT is what is QT? As I said that I is equal to Q by T. So what will be the formula? That is, 1 minute, this is QV is equal to Q and P will be equal to VI. So P will be equal to VI, that is power is nothing but voltage into current, and instead of I we can replace it by V by R, that will be equal to V square by R, and V can be replaced, that we will get as I square R. These are the formulas for power. So similarly we will get the commercial unit for power, that is kilowatt hour, that is kilowatt hour. So as I am explaining, just download this mind map and keep with you, you can observe there. So what is the formula for power? V is equal to VI, P is equal to VI, and what is the commercial unit? That is kilowatt hour. So I will be telling you how to measure the current, how to measure the power in the households. So before that we will be discussing how this unit comes. So let us find the value of kilowatt hour. So what is meant by kilo? Kilo is nothing but 10 to the power 3. And what is watt? Watt is nothing but watt itself. And what is hour? Hour is nothing but how many seconds are there in hour? Hour has basically 60 into 60. So what we can say that 60 into 60 is 3600 into 10 to the power 3. So we can tell that 3.6 into 10 to the power 6. This is becomes Joule, 10 to the power 6 Joule. Kilowatt is nothing but 10 to the power 3 Joule, and our time, that is 3600 seconds. If we multiply, we'll get as 3.6 into 10 to the power 6 Joule. So I have completed this sessions with mind maps and exclusive animations. So let us end this session. The electricity chapter is completed, and don't forget to download the mind map and watch the first part if you have missed the first part. So thank you friends, and please subscribe to my channel and press the bell icon to get new notifications of new videos.